Alright class, today we're our Algebra 1. We're going to go over Lesson 2-3, which will be the last lesson in this unit. Um, it is over arithmetic sequences. So first off, we needed to, you've been dealing with sequences for quite some time in school now. It's a type of pattern that you've dealt with before. But what is a sequence? Well, in this context, it's going to be a set of numbers. Okay. Whoops, my pen won't work there. There we go. It's going to be a set of numbers, which is going to be in a specific order, which will be determined, that order is going to be determined by any mathematical operation. Okay. So by that we mean addition, subtraction, multiplication, division, or any. As you get further along in your math career, it could be combinations of those things. So anyway, examples are as follows. You'll see 1, 4, 9, 16. Hopefully you can see what's happening there. We went up by 3, and then we went up by 5, and then we went up by 7. So you should be able to pick out what would be next. We're going up by odd numbers, right? Here, this next one, pretty simple. 2, 4, 6, 8, 10. Going up by 2s, or counting by 2s there. The next one might take a little bit more. 6, then 24, then 96, then 384. You might initially think you were adding to get to 24, but you wouldn't add the same amount to get to 96, so that would probably take you to multiplication. So you multiply 6 by 4 to get to 24, and then you'll notice that 24 times 4 would be 96, and 96 times 4 would be 384. So I'd like, I'm going to pause, you'll pause the video here, and why don't you go try to find the next 2 terms in each one of these sequences. Okay, now that you're back, hopefully, you will notice, whoops, let me scroll down a little bit so you'll be able to see. Hopefully you'll notice here, what did you do? Find the next 2 terms of this one. You notice right away that that's going up by 10s. And here's a good, or a way that I like to show this sequence happening. We're adding 10 each time. So our next 2 would be 65 and 75. When you went over to this next one, hopefully you notice that you weren't adding or subtracting the same amount each time. So you had to go to multiplication. Well, to get from a negative to a positive, you must have been multiplying by a negative value. And you'll notice when you do that, it alternates back and forth here. So we were multiplying by -2 each time. Get to -32 and 64. Now the next one, there's actually 2 different ways you can look at it. The first of those, which we'll show here by a show of hands when we're in class who thought of this, but these were all what we call perfect squares. So this is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. And if you notice that, you would have gone on to 49 and 64. But there's another pattern, which is what we talked about up here, if you remember. If you didn't necessarily recognize that those were perfect squares, you might have recognized that it was going up by odd numbers every time. It went up by 3, 5, 7, 9, 11, so we need to go up by 13 and 15. There's a connection there. We'll go over a little later. Okay, so let me get down there. Alright, so one important take out of this is each number in these sequences is called a term. That is something you need to get, or you need to be comfortable with. So take this one for instance. This is term number 1, term number 2, term number 3, 4, 5, and 6. So there, not only is there a value to go with each term, but there is a term number that's essentially its position within the sequence. That's important because that will come into play as we write these equations. Okay, what we're going to deal with today is a specific type of sequence called an arithmetic sequence, and it is a sequence that is going to either increase or decrease by some constant value. Each new term is going to be found, if it increases or decreases, it will be found by either adding, or if it's decreasing, we would have to subtract, right? Or subtracting that constant value from the previous term. Okay, so in order to get the next term, I have to adjust somehow by either adding or subtracting from the previous term. Okay, that common difference, or that constant value that we are either going up by or down by, we will refer to as D, because we call it the common difference. Okay, so here's an example of an arithmetic sequence right here. I'd like for you to take a second and find that common difference here. Okay, so find the common difference. So I want to know what D equals. Okay, so you should probably notice that it appears you are subtracting 5 each time. So that difference is 5 and we are subtracting that. Therefore the common difference will be -5. Alright, we're going to move on. We're going to talk a little bit about the formulas that we can use. The first one is very basic. It's simply one that is going to be used to find the next term of a sequence. So if we know a previous term, this is going to be a simple formula to find that next term. Okay, so this simple and we call this a recursive formula. A recursive formula will allow us to find the next value. So that we're going to be very basic in our explanation of this equation. We're not really going to use, instead of using a variable here, we're just going to say we're going to find the next value. And in order to find the next value, I need the value that we have right now, and then I am going to add that common difference. Now it's important to note that that common difference represents in itself whether it's going up or down. If you are increasing, then that common difference is positive. If that sequence is decreasing, then that would be a negative, and you would be adding a negative value, thus subtracting and decreasing that. Okay. Let's look at this simple recursive formula right here, and let's write the first 5 terms in this following sequence. So if we've got our recursive formula is next equals now plus 3, and it's telling you it wants to start at 10. So my first term is going to be 10. I know that already. Okay. Now to figure out the next term, I would take the term I already have, or the now value, which would be 10, and I'm plugging it into the formula, right? So simply it's 13. Now I know that if I told you the starting value was 10 and the common difference was 3, you'd be able to just list all these off. But as we get more complicated, it's important to be able to understand that to get the next value, you take the previous value or the now value and add that common difference. Okay, so 16 will fall here. I'll add another 3 to it to get 19, and for our last term we'll have 19, and I'll add another 3 to get 22. So those terms are 10, 13, 16, 19, 22. Okay. Now we're going to talk about writing one of these recursive formulas if we are given a sequence. So, if we were given this, we should be able to come up with this sequence or this formula right here. So, the first thing you want to do is verify that your sequence is in fact arithmetic. So you want to make sure it's going up or down by some constant value. Next, you're going to want to identify the starting term, which that's pretty easy. It's the first term. And then the common difference. So you look at what you are either adding or subtracting. Remember, if you're going down or subtracting, then that common difference is negative. Okay, so let's take a look. Why don't you guys try this on your own? Hit pause and give this a shot on your own, and we'll come back and fill in the blanks. Okay. You should notice right away that this is in fact arithmetic, and if you notice that it is arithmetic, then you had to come to the conclusion that you were going down by the same amount each time, and that amount was 8, so that makes the common difference -8 since we were going down. Starting term is of course 62. Easy enough. So simply this formula then is my next value is going to equal my now value or current value. And what am I going to do to it? I'm going to subtract 8 from it, from whatever that previous value was. And for this particular sequence right here, we were starting at 62. Okay, over here, this was also arithmetic. We knew that we were going up by 13, starting at 28. So when I'm writing this formula, I would take the now value plus 13, starting at 28. And that's pretty much it for writing these recursive formulas. In order to find the next value, you have to know the previous value and the common difference. Okay, we're going to shift these recursive formulas into function notation. To me, this is a more practical application here because it well, it goes along with what we did last time, and the function notation kind of builds upon that. But it also kind of breaks up the formula and allows you to plug in different values here and there. So just follow along here, and we'll get into function notation. So this is going to be in place. This is just another recursive formula. It's going to be in place of that now next formula that we just talked about. Okay. And this is going to be in function notation again. So the formula goes like this: f of n plus 1. So when you're thinking about that, you should realize, hey, that makes sense, because instead of f of n, I have f of n plus 1. That would be the next value, right? So what would be the now part of this? Well, if this is f of n plus 1, this would just be f of n. And remember that what do we do to that previous value to get the next value? We add our common difference. Okay. So filling in the blanks over here, n is going to be our term number in this. Okay, so if I'm looking for the first or second or third or fourth, that's what goes in here. Okay. F of n is what we will refer to as the nth term, and that is like the now term in that previous recursive formula that we wrote. F of n plus 1, that's the n plus 1 term, or the next term. Okay. As we know from the previous slide, D represents the common difference, and that can be positive or negative, remember. And it's also important to know that f of 1 will be our starting term here. Okay. So let's look at an example here. We're going to write the first 4 terms of the following. If we have f of n plus 1 equals f of n plus 11, when the first term is negative 10. Well, if we're going to write the first 4 terms, they've already given me the first term. That's easy enough. So in order to find the second term, what should go here? A 2. If this is 2, then what must f of n have been? That would be the first term, right? And remember, the formula has me adding 11 each time. Okay. Let's go along this way instead of going ahead and solving these right now. If I wanted to find the third term, what would I do? Think to yourself. Try to write that down on your own. Well, if I wanted to find the third term, I need the previous term, which would be f of 2, and I'd add that 11 again. And for the fourth term, I want the term previous to that, and I would add 11. So you can see how this just builds on itself. Okay, let's go back and go ahead and solve these. F of 1 was negative 10. When I add 11 to that, I get 1, right? So f of 2 is now 1. F of 2. Therefore, that's 1 plus 11 to get 12. So f of 3 is 12. So it can go in here. Plus 11 equals 23. So f of 4 is 23. So my first 4 terms go like this. Negative 10, 1, 12, 23. That's my first 4 terms there. Alright, so that is covering the recursive formula. And remember, back from this other slide, that allows you to simply find the next term of a sequence if you know the previous term. What we're going to move on to now is an explicit formula. And what an explicit formula allows us to do, it doesn't allow us to, wow, I evidently lost the ability to write earlier. Let's see, that should be find, not thing. Let's get that here. Alright, now we're good. Alright, so that explicit formula is used to find any term in a sequence. So while the recursive formula only allowed us to find the next value, this explicit formula is going to allow us to plug in some value for n. For instance, if I want to find the 8th term, I can get a formula and plug in 8, and I can find that what that 8th term will be. Okay? And this explicit formula goes like this. It's going to be written in function notation. So a of n is going to be equal to a of 1 plus. Now we're going to take that n and subtract 1 from it, and we're going to take that times the common difference. Okay? So again, n is going to be our term number. That's the first, second, third, fourth, fifth, whatever term you want. Remember that that is the place within the sequence. It has nothing to do with the value that's in that place. It just has to do with its position. Is it in the first position? Is it in the fifth position? Where is that term? Now the nth term is what we will call the now term. It's what we're trying to find, right? So that's the a of n. The a of 1 is the first term. And again, d is our common difference. And those are the things you'll need to know in order to write these explicit formulas and use them appropriately. Okay? So here's a little example. It says if given a of n equals 3 plus n minus 1 times 7, I want you to identify the starting value. So what is the starting value or the first term of that sequence? Well, look up here and match up the first term. It looks like that starting value should be 3, right? And what is the common difference? Well, it goes at the end here, so that common difference must be 7. So what that should mean to you is I'm starting at 3 and I'm going up by 7 each time. So to tell me the next few terms shouldn't be that difficult. We'd be at 3, and then we'd be at 10, and 17, and then 24, and then 31. But do you really want to add 7 23 times? I don't particularly care to do that. So that's why we have this formula right here. If we're going to find the 23rd term, I need to know first off that that is represented by a of 23. Okay? Because I'm looking for the 23rd term. That means my n value, or the 23rd position in that sequence. Okay? Well, if n is 23, what was my first term? What goes here? My first term is 3 plus, and then n minus 1. I know n now, right? So I can fill that in. 23 minus 1. And then I know d, which is 7. Okay, now I want to stop and explain something here, just to use some common sense. If I want to know the 23rd term and I am starting at 3, okay, I know I'm adding 7 each time. How many times would I add 7 to get to the 23rd term? If I'm already at the first term, think about how many times will I add 7 to get to the 23rd term. And when you think about it, you might initially say, well, I'd add it 23 times. But I'm already at my first position, and I have to get to my 23rd position. Okay? So I would actually only add 22 sevens, and that's where this formula comes from. The n minus 1 is how many times you would add that common difference. Well, we know that repeated addition is the same thing as multiplication right here, right? So remember, in math, you can never forget anything. Everything builds on itself. So this repeated addition, instead of adding 7 22 times, I'm simply going to take 22 times 7 and take a little shortcut here. So I would have 3 plus 22 times 7. And I know my order of operations. I had to do that in parentheses first, right? And now I can do my multiplication. So I've got 3 plus 154, which means that this 23rd term would be equal to 157. Okay. Now the last thing we're going to go over today is writing an explicit formula, which is going to allow us to find not only the term values like we just did, but it will also allow me, if I'm given a value, to find what term number that value is located in. Okay, and we'll do a quick example of both of those. Writing the formula shouldn't be too difficult after we just did it here. It wants us to write the formula and find the 15th term for this sequence right here. Well, identify that first term. That's pretty easy. I can do that. Identify D. So is this going up or down? This is going up. It is increasing, right? It started at a lower negative number and it is increasing towards the positive numbers, which means it's going up. And that common difference, it's going up by 12 each time. So when I write this explicit formula, I start with the first term. So I will start with negative 54. And remember, I add n minus 1. I have to have that n in there because I have to be able to plug something in to find these values. And my common difference is 12. So when it wants me to find the 15th term, I'm simply going to plug 15 in. Negative 54 plus 15 minus 1 times 12. Remember, to get the 15th term, I would add 12 14 times, right? So instead of adding 12 14 times, I know that repeated addition is multiplication. Plus 168. And the 15th term is equal to 114. So 114 is in the 15th position of this sequence right here. Okay. Now the other use of an explicit formula is if I was given a value here, I want to know where this value falls in this sequence. Is it in the 10th position? Is it in the 30th position? I don't know. But I have certain values here. I want to know when I'm going to get to this one. So identify the first term again. First term 75, right? The D, it appears to be decreasing, right? Decreasing by 15. Therefore, D would be a negative 15. So everything's the same here. I'm still writing the explicit formula. I start with 75 and I add n minus 1 times the common difference, which was negative 15. Notice that you always add here. If you are decreasing, it will be taken care of by the negative value for the D. Okay? So don't be tempted to subtract here because you're decreasing. That's taken care of here with this negative. So now the only difference is I've not been given a term number to find, right? I've been given a value for the whole term. So I haven't been given n. I've actually been given a of n. I actually know this whole thing. So I'm going to substitute this value in for that whole thing. So negative 210 equals 75 plus, see, I still don't know what n is, right? That's what I'm looking for, times negative 15. Now there's a trick here that will keep you from having to distribute and then solve this. So I want you to pay real close attention to how I do this, because I'm not going to write it out. I'm just going to verbally tell you what I'm doing. The first thing I should undo and move is this 75, right? I need to move this 75 over. How would I do that? Well, I would subtract it. When I subtract 75 from both sides, I get negative 285 is equal to, I still have n minus 1 times the negative 15, right? And now, here's what will shorten things up. I'm multiplying by negative 15, correct? So what would I do instead of distributing and then getting rid of everything? Why don't I just, instead of multiplying by negative 15, divide both sides by negative 15, and that will leave me with just n minus 1 over here, and negative 285 divided by negative 15 is 19, and then all I have to do is simply add 1 to both sides, and n equals 20. Negative 210 is the 20th term in this particular sequence. Alright, thanks for following along, and we will see you in class.